Hi everyone, welcome to my session. My name is Anastasiia. I'm a Snowflake data superhero, and today I'm very excited to welcome you because I think we're going to build something exciting together. As you learned from the description or name of the session, we're going to build a movie recommender. It's going to be a fun demo, no slides, I promise. And we're going to use a family of Snowflake Cortex functions as well as Snowflake Intelligence to see how to put it all together. Without further ado, let's get stuck in. I'll share my screen. And let's see what we have here. So we start in the Snowflake account, a couple of first steps that we always have to do, creating an environment. In this case, we're going to use the database and the schema, which is build demo, IMDb data, just to make sure that everything we create today sits in one place. Okay, now with this out of the way, what's the first step of building a movie recommender? You might ask me, and finding the data is going to be the answer which I'm going to provide. So in Snowflake ecosystem, the most convenient way of finding public available data is a Snowflake Marketplace, conveniently located on the left panel. And here already I have pre-searched and found this fantastic free dataset with unlimited access, which we will be using today for training our recommender. We can scroll and see the description of this data product and this data set. You see that it has really extensive data. Let's have a look. Here we can see all the columns which the data has. I will be interested in a few. I see already some good candidates, ratings, storylines, titles, URLs. Yes, those are the columns I want. How do I get them? Okay, you probably saw this button, which I'm going to click in a second, which says Get. As I mentioned, this dataset is free, so you can use it in your account, even a trial account, and you can use it without incurring any storage costs, which means, as you also see here, you just pay when you actually query the data for the warehouse usage. The data doesn't get copied to your account, which is quite convenient. Let's see. The options we need to check is the database will be reflected in our account as AI training dataset from IMDb. And since we're in demo mode today, we don't need to grant access to any other roles. Let's get the data. It will take just a brief second, really. And after just a few seconds, we already see that we can query the data, and it will bring us into an interface of a sample query. So here, the provider of the data has created a sample query for us to have a look at the data. Right, what do we have here? Title, genres, rating, count, top cast, storyline. I remember there was also URL, and I must confess, I never remember the names, so I'm going to remove the cast for now. I'm also not only interested in thrillers, and I don't want to limit myself to ordering by, I don't want to order by the rating. I want to maybe expand the limit to see some 30 results. Let's have a look how it is. And of course, we have an error because I forgot to include the name of the database, which you should always do. And this proves that this is a live session. So here you go. I just included the name of the database. Here are the results as we see them coming. IMDb ratings distribution, really cool feature, love it. Also some URLs, a storyline, and genres, titles, superb. I have what I need. I think I'm going to use this data. I do, however, want to have a polished version. So back to my original SQL. I want to create a table for the purposes of this demo, which is called IMDb Movies. It's gonna include what I really need, which is title, description, URL, and rating as selection from this data set which we have. So let's run this query and make sure that our table, which we're going to use throughout the whole demo today, it's created already in under 3 seconds. Let's see how it looks. Okay, perfect. I see the title, looks good. The description, that's what I need. The URL, which brings me to IMDb website, super cool. And the rating when it is available for the movie in the dataset. Great. Now I have the data as I wanted to. What's next? For movie recommender, as a first step, I would like to find the movie without knowing its title, without knowing the exact description, by just providing some information what I would like the movie to be about. How do I achieve that? When we talk about the fuzzy logic, and what I just described as an example of a fuzzy logic, not an exact match, then we use Cortex Search. Cortex Search is a hybrid search. It's a combination of a vector embedding and a keyword search. So we're going to create a Cortex Search over the description column because that gives the information about the movie, and we're going to do it straight away. Let's go to the Cortex Search panel over here and create a search. We're going to use the database and schema we have just created, and we're going to call it IMDb Search. To select the data, we take the table that we have created. For the search column, as I just explained, we would like to use description because that contains the, well, description or the plot of the movie. And we would like to be able to search by feature, not by the title. Now, for the attributes, these are the things that we would like to use as filters. I would like to use rating as a filter because I only want movies with the higher ratings. And I would also like to include all of the columns as an output. So include in the service means include into the output. And I would like to include all the columns of my table into the search. Configure indexing. That's the last part that's connected with the refresh of the data. Since we know that in our data set, we just created the table, we do not plan to refresh it in this demo. Our lack of 1 hour is completely fine with me. If you, however, have a production situation where the data is refreshed frequently and Cortex Search has to be always up to date, then you're able to tune it to minutes or maybe even days if the opposite situation is of interest to you. Now, the other settings here include the embedding model. That's what's going to create the vector embedding. Arctic Embed version 1.5 is what we're going to use. It's the default, it's the performant English model. So we are fine with the English language for this data because it is in English, and we're going to keep it as is, but there is also other models available for you. The warehouse for indexing is what a warehouse we're going to use for processing this task. We're going to leave it as default and click Create Search Service. Now, search service is initializing, and we know that it's currently indexing the description data, and we can leave it to finish while we create other tools. The next tool. Something that I would like to do after I found the movie, which fits the description with Cortex Search, is making sure I have an option to retrieve the information from the table which I have just created. Cortex Analyst is exactly that. Cortex Analyst is text-to-SQL capability, which converts the human question into the SQL and allows us to query the table in the background. Let's create a Cortex Analyst. To create Cortex Analyst, we need to provide the context about the table, the semantic information. You can do it as a semantic model or as a semantic view. Semantic model is a YAML file, and semantic view is a view which lives in the database and schema that you define. We're going to use the view today, but feel free to experiment if you're curious about the YAML models as well. So we're going to store it in the same database which we have already created, and we're going to call it IMDb semantic view. We're going to click the next and select the table which the view is going to relate to. In this case, my table is IMDb data, IMDb movies. I want my semantic view to know about all of the columns in my table. Sometimes some columns might not be relevant for the semantic view. They might confuse it. So we don't want to include columns if they don't have a business logic or business meaning. In this case, since we've just curated this table, I know that all of the data is relevant and I plan to use it all. I'm going to include all of the columns. I'm going to ask it to add the sample values and descriptions to the semantic view. Let's see how it does, because it's going to be done with AI. It's going to deduce the descriptions and synonyms and the descriptions and the sample values from the data it sees, and it's ready already. So what do we have here? Let's look together. We have a logical table which we defined, can be more than one, but in our case, one is enough. And then we have dimensions, which are categorical values, features of the data. For movie, that would be description, title, and URL. And we have facts, which is the rating, which is numerical value of the data, which can also be somehow aggregated. Let's go step by step and add some business context to this semantic view. This is the operation which will allow the semantic view to be accurate. This is embedding the knowledge and wisdom of yourself as a domain expert or analyst into the Cortex Analyst, transferring the knowledge so the model later can pick it up. For example, description of the movie, as I already called it, can also be called a plot. So I'm going to add a synonym to the word, to the column name description, and it will be a plot. I also know that there is a Cortex Search existing on my model on this column. So I'm going to use it for IMDb data, and I'm going to connect the Cortex Search to the column in the semantic view. Great, I click Save here. For the title, I think I'm going to add the synonym name, because it could be called a movie name. And I'm going to just click Save. No Cortex Search connected to the title. And the URL, I'm just going to add a link as a synonym, because this is what people call it. Now, for the facts, we have a rating, which is a fact, which can be aggregated. And we would like to make sure that our semantic view knows that if you have ratings, you normally aggregate them by average, like what's the average rating of all the thrillers on IMDb. There you go. Click Save and make sure we save it again. Now we have successfully built our second tool. So we now have Cortex Search and Cortex Analyst, two tools which can be used by our movie recommender. But how is going to know what to use when? That's when we're going to use the agent. Agent will serve as an orchestrator between the tools, and let's create an agent together. We are starting to create an agent in this window. The agent name would be IMDb agent, and the display name will be movie recommender. We create an agent. Now we would like to add tools to the agent. For this, I'm going to start by selecting the Tools section, adding the Cortex Analyst semantic view, which is stored in our database and schema. And here it is, a user-friendly name, semantic view. Description: use this tool to search in the table of IMDb movies. We keep the warehouse at user's default, and we don't need a timeout here, and we save it. Our second tool, Cortex Search, again, we select where is it living, and we add our Cortex Search as a tool. The max result feature here is something how many results we want to return by default. I would say 3 is good. ID of the column used to generate hyperlinks. We have a URL. Title column is something that we have as well. It's going to present the title of the data it found. And we could just say as a filter, we can have a rating, and the tool details would be search, and let's just keep a rating here, and description that we want to add will say use this tool to find a suitable movie based on the description. We add the tool. Now, we also have an option here to add the custom tools, but we don't have them for this demo. Those would be, for example, UDF or stored procedures. So you can define your own custom tools in Snowflake, but for the movie recommender, I think we're good with what we have. Just making sure in the orchestration section, we have a look real quick on the instructions that we can provide and the response instruction. For example, response instruction could be summarize the movie description and provide a rating. For the orchestration instructions, use search to make a selection and analyst to query data. Amazing. So with those simple instructions, or even without them, we can save our tool now. Now we have an option to test the tool in the user interface. Snowflake has created a user interface on top of the agents, which is called Snowflake Intelligence. So for now, we've built everything which is a backend. Now let's see how it feeds into the front end of the system. For that, let's go to Snowflake Intelligence. A new interface, very user-friendly, and we have a movie recommender already selected for us, and we can ask a question to the Snowflake Intelligence. So let's ask something inspiring. Recommend me a movie which motivates me to learn some new technology and perhaps connects it to some scientific research and has a great rating. If only I could type, but worry not, even if there would be typos, I'm sure that it would understand it. What's happening here? Now let's show some details. First, Snowflake Intelligence, powered by Snowflake Agent, plans its steps. It will search for movies that combine technology, scientific research, and motivation. It will analyze the ratings of those movies, and then it will summarize it into a recommendation. Well, those are the planning steps. They sound good. It starts by searching for some movies. Now, as a next step, it goes with planning checking the ratings for the movies and using the semantic view to ensure that they recommend a highly rated one. And here is the query it does. It uses title and rating, which is what you would expect it to do, based on the movies which it has found in the previous steps. Planning the next step after the execution of this query is also fairly straightforward. It can now make a well-informed decision and builds it up into a recommendation, and let's see what we have. It recommends us a Pursuit of Happiness rated 9 out of 10. It gives some summary, and it says it embodies the spirit of learning new technology and connecting to practical application. It even builds up some analysis over the movie description, which is particularly useful to anyone who worked with data. You know, it might be a daunting task to put together that summary after you have built up your analysis. So here it is for you. Also, it suggests alternative options like Free Energy of Tesla about Nikola Tesla's life, or Who Said You Can't. Look, over here, you also have references to the movies it recommended, and if we would be interested to see one, it would bring us directly to the movie page of the IMDb. So with that, we have built our own movie recommender, and hopefully we can enjoy a nice evening which would still keep us motivated to learn in pursuit of new knowledge, as you've joined today in pursuit of new knowledge at this session at Build. Thank you very much for joining. That's the end of the demo and the end of my session. It's been a pleasure and delight having you today. I cannot wait to see what you built. Please share it on your socials, and I will be making sure to tag me, and I will make sure to review and compliment your work. I wish you the best in this and enjoy the rest of the sessions.